but it can be used. Okay, so now we go back to our indefinite integral. We've got the integral of u to the negative third, and the dx will be du over 4. This is a good choice for you because I have no more x's left over. And so I'm almost ready to take an antiderivative. Now this 4 here in the denominator, to make my life easier, I'm going to pull that to the front. And because that 4 was in the denominator, it becomes a 1/4 when I pull it to the front. So I have 1/4 the integral of u to the negative 3 du. Are there any questions up until there? We made a choice for u. We've substituted in, turned our integral entirely into u's. Now we can take our antiderivative. So 1/4, we're going to add 1 to the power, so we've got u to the negative 2 divided by negative 2. And then we've got a plus c at the end. All right, we've taken our antiderivative. Life is good. Our final step is turn this guy back into x's. And so we've got, well, 1/4 times u to the negative 2. So our u value is 4x plus 3 to the negative 2 divided by negative 2, and then a plus c. And technically, this is a valid final answer. I'm going to clean up the fractions a little bit. And so I end up with 4x plus 3 to the negative 2 divided by negative 8 plus c. Either of those two would be perfectly fine final answers. As would negative 1/8 times 4x plus 3 to the negative 2 plus c. Okay, any questions about that one? All right, so we've talked about indefinite integrals. For our final 10 minutes of class, I want to talk about definite integrals with u substitution. So what happens when you start to throw boundaries into the question?
Don't you have to use the fundamental theorem with f minus f of a?
Yes, so we're going to have to use the fundamental theorem. So we're going to need to find an antiderivative and plug in the boundaries, but there's a twist that's going to happen. Okay, so let's take a look at our definite integrals. And our first example will be the integral from 0 to 1 of 12x squared times 1 plus 2x to the third raised to the 5th power dx. All right, now there are two options to work with here. Okay? When we have the boundaries throw a kink into our process. So one option, so when we want to use the boundary, we have to find an antiderivative, plug in the boundaries, and subtract those values. So one option, option 1, is to look at the indefinite integral. Okay, so we can look at the integral of 12x squared times 1 plus 2x cubed raised to the 5th dx, and evaluate this indefinite integral. So let's go ahead and do that. In this case, I look at it and I see a bunch of stuff multiplied together, but more importantly, I see fanciness inside the parentheses. I see something that is nested inside of our function. And that's my choice for my u. So I've got u is equal to 1 plus 2x cubed. And so when I take this derivative of 1 plus 2x cubed, I get du over dx is equal to 6x squared. And when I solve that for dx, I have that dx is equal to du over 6x squared. back over here to my indefinite integral, and I've got the integral of 12x squared times u to the 5th, and my dx is du over 6x squared. Alright, so at this point I'm sweating a little bit because I'm very uncomfortable with this situation. I've got x's, I've got u's. If life is good, then all of my x's cancel, and life is good. My x's cancel, and in fact, I can even simplify with the 6 and the 12, and so I've got the integral of 2 u to the 5th du. Alright, so I've turned it all into u's. Now I can take my antiderivative. So I add 1 to the power and divide by that new power. Tack on a plus c, and I may even simplify this a little bit, and I'll simplify to 1/3 u to the 6 plus c, and turn back into x's. So I've got 1/3 times 1 plus 2x cubed raised to the 6th power plus c. Now, here's the unfortunate part. We're not done. So remember what our goal is. Our goal is to evaluate this definite integral. And the work that we've done is the work to find the antiderivative of the thing in the middle. And so now back to our definite integral. The integral from 0 to 1 of 12x squared times 1 plus 2x cubed raised to the 5th dx. Well, we just found an antiderivative for that guy in the middle. Our antiderivative is 1/3 times 1 plus 2x cubed raised to the 6th, and I'm going to evaluate that between 0 and 1. So I had to do this extra work in the middle. It's almost like an aside to come up with an antiderivative for this fanciness up here. All right, so now I can plug in my boundaries. Are there any questions up till here? All right, at this point it's plug and chug. I've got 1/3 times 1 plus 2 times 1 to the 3rd, all raised to the 6th. Minus 1/3 times 1 plus 2 times 0 raised to the 3rd, all raised to the 6th. And so this actually isn't that bad of a value to work with. We've got 1/3 times 3 to the 6th minus 1/3 times 1 to the 6th. And so, if anybody know what 3 raised to the 6th is?
729.
Thank you. Okay, so we've got 729 over 3 minus 1 over 3 is 728 over 3. Okay, so big picture is we want to find the area under this function between x equals 0 and x equals 1. In order to do that, find an antiderivative, plug in the boundaries, subtract them. The trick, or the harder part, was what the heck is the antiderivative of this thing? In order to figure that out, we had to do an aside on the indefinite integral. We had to do all this side work here to come up with our answer. All right. Alternative method here.